Suppose 3 students win gold, silver, and bronze medals. If Alice gets gold and Bob gets silver, is that the same outcome as Bob getting gold and Alice getting silver? Of course not. The order matters, and whenever order matters, we're dealing with permutations. Let's learn how to count them fast. A permutation is an arrangement where order matters. Swapping positions creates a completely different outcome. When choosing R objects from N objects and order matters, use this formula. N permute R or N pick R equals N factorial over N minus R factorial, where N is the total number of objects available to choose from, and R is the number of objects being selected and arranged. The factorial notation N factorial means multiplying all whole numbers from N down to 1. For example, 4 factorial equals 4 times 3 times 2 times 1, which is 24. You can check out my video on factorial if you need some more help. For example, a club has 10 members. They need to elect a president, a vice president, and secretary. How many different ways can this be done? Well, first we need to identify N and R. In this case, N equals 10, there are 10 members, and R equals 3 because there are 3 positions to elect. Applying the formula, 10 permute 3 will be equal to 10 factorial over 10 minus 3 factorial, which will be 10 factorial over 7 factorial. So we can expand the numerator. That will be 10 times 9 times 8 times 7 factorial. And 7 factorial and 7 factorial in the numerator and denominator will cancel each other out. So we'll be left with 10 times 9 times 8, which is 720. So there are 720 possible officer selections. In this next example, 8 runners complete in a race. How many ways can the gold, silver, and bronze medals be awarded? Now N equals 8 because there are 8 runners, and there are 3 medals to be awarded, so R equals 3. Applying the formula, 8 permute 3 will be equal to 8 factorial over 5 factorial. And if we expand and solve, that will be equal to 8 times 7 times 6, which is 336 possible medal outcomes. How many ways can we arrange the letters in the word math? There are 4 distinct letters, and we are arranging all 4. So if we use the factorial methods that we learned in the previous video, 4 factorial will be equal to 4. There are 4 letters to choose from for the first position. Then there will be 3 letters to choose from in the second position, 2 letters to choose from in the third position, and finally there's only 1 letter left. So there will be 24 different arrangements of the letters M, A, T, H. Or if we use the permutation formula, out of 4 letters we have to permute 4. So that will be equal to 4 factorial over 0 factorial, which will be 4 times 3 times 2 times 1, which is 24. And we know that 0 factorial equals 1. Both methods agree. There are 24 possible arrangements of the letters in math. So here's your challenge for today. A school yearbook committee needs to choose president, vice president, treasurer, and secretary from 12 students. How many different selections are possible? Pause and try it before scrolling to the solution. Here's the solution. Out of 12, you permute 4. So that will be equal to 12 factorial over 8 factorial, which will be equal to 12 times 11 times 10 times 9, and that will be 11,880 possible officer selections. Students often ask, why can't I use combinations here? I'm just picking people, the formula doesn't matter. But that's the wrong thinking, because president does not equal vice president. The positions are different, so changing the order creates a different outcome, and that's exactly what permutations count. Always ask, does swapping positions change the outcome? If yes, use permutations, not combinations. So remember, a permutation is an arrangement where order matters. Swapping positions create a different outcome. The formula n permute r or n pick r equals to n factorial over n minus r factorial. Race results, class officers, passwords, and seating arrangements all involve permutations. What if order doesn't matter? Suppose we're choosing 3 students for a comedy. Does it matter who was chosen first? No. That's where combinations come in, and that's what we'll discuss next. Thanks for watching. Please like and subscribe and share. And don't forget, math success starts when you stay on the fast track.